Welcome. This is bonus content, Lecture 14 for Norwalk Community College students. Bonus content that a lot of teachers don't cover, but the nice thing about this bonus is it's not to make it some ridiculous question that nobody needs to know. This is a way to try and help you decide before you do the work which way to go after the problem. Here's the story. A lot of teachers will say, solve this using the three-point method. Then they'll say, solve this using intercepts. And then they'll later say, solve this using slope-intercept. And they want to make sure you know all three of the tools, but you don't learn anything about diagnosing the problem. That would be like a doctor saying, oh, solve this with penicillin, solve this with cough syrup, instead of thinking about what they're doing before they do it. So we're going to think about what we do before we do it following this process, now that we know how to do intercepts. When they are good, they're awesome. They're easy to graph. They're easy to find for some people. So I want to let you know, I didn't hold back on you and say, let me teach them something really nasty and then show them intercepts, and they'll always use intercepts. Here's what the story is with intercepts. Graphing intercepts is one of three things. If it survives the first, we'll look at the second. If it survives the second, we'll look at the third. If it makes it to the third and passes the test, intercepts are just probably the best way to do it. Here we go. Number one, solving this with intercepts is possible if we have two variables, x and y usually, and a constant, which is a number with no variable on it, that is not zero. So x, y, and a number that's not zero all have to be in there. If that happens, it's possible to find two intercepts, which you could put on the graph. But then comes number two. Wouldn't it be nice if what you found was graphable? So graphing using intercepts is graphable when you already know it's possible, with integers for all of its coordinates if the constant divides by each coefficient evenly. So what's going to happen is we're going to make a decision as to whether or not we should go after it this way, because if we wind up with it saying, here's one of them, 0, 4, awesome, and here's the other one, -5/3, 0. That means you have to graph -5/3, -5/3, roughly -1.6667, 1 2/3 in the negative aspect. If it's got a fraction on it, it's hard to graph. To me, 2/3 looks like 3/4, can look a lot like some other things like 5/8. There's a lot of stuff that looks the same, but 2 never looks like 3. So that's why I say it's graphable if we get integer coordinates. And it's simple if you do find it's possible and it's graphable, and if the constant is isolated. What's going to happen, that's going to be graphable whenever we have that situation. It's got the two variables as well as a non-zero constant. It's such a case where we can divide the number by the coefficient of each of the terms that we have wherever they are. We don't have to worry about negative or positive at that moment, just to see if they make integers. It's simple if the constant is isolated. So here we go. First one, graph y equals 4. Is it possible to graph that with intercepts? The answer is no. It is not possible because we don't have an x. We have just a y equals 4. It's not going to have two intercepts. It's not going to have an x-intercept and a y-intercept. It's only going to have one of those. It's going to have some point where y equals 4, and in that case, it's okay to let the x some of the time equal 0, and you get 0, 4. Turns out that does have a y-intercept. But there is no way, since y is locked on being 4, that y can ever be 0, so we can't do this with intercepts. So that's out. This is not possible. I always say Einstein couldn't do this. It's not a matter of smarts, it's not a matter of skills, it's a matter of what's even possible. So you can't do that. Here's another one. 2x equals -7y. There's an x term, there's a y term, there's no other constant term. Also not possible. So you could stay there all day, or for life, or for an eternity, and you'll never be able to graph that with intercepts. So don't think intercepts are always going to work. Problem with this one is one intercept is going to be 0, 0. Let's say that's the x-intercept at the origin. The y-intercept is also going to be 0, 0. So then what you have is you put down one red one and one green one. They both are on 0, 0. You don't have a second point. You can't make a line, and we need 2 points to make a line. So those are both impossible. So now we try 3x plus 4y equals 7. It's got what we need. This is possible. Good. So let's do it. I'm not going to do it in red and black because my point here is to show you what's nasty about having it happen. 7 divided by 3. Does anyone know what that is? awesome if you can tell me what it is in the sense of it's 2 1/3, but you heard the 1/3, that's a fraction. Because if we do that, we're going to have a problem. 7 divided by 3 has got to be graphed on the axis, and it's not going to have a place to land on an integer. 7 divided by 4, also difficult. It's 1 3/4. The 3/4 makes it hard to graph. So this is not graphable. What would happen? If we let x equal 0, we'll get 3 times 0 plus 4y equals 7. That's 0 plus 4y equals 7, and 4y equals 7. We divide by 4, and y equals 7 over 4. So then it does happen that y equals 7 over 4, and that's got the 0. So we could graph it, but that I consider not graphable as an integer. What about the other one? I mean, it's over. This is bad enough. This is doubly dead because if we let y equal 0, then we're going to see 3 times x plus 4 times 0 equals 7. 3x plus 0 equals 7, therefore 3x equals 7, and we're going to divide by 3, and we'll see that x equals 7 over 3. Ordered pair, 7 over 3 goes in for x and 0 for y. Those are both brutal to graph. You can do it. It is possible to do it, but then your job becomes accurately graphing 7 over 4 and 7 over 3. And my guess is if my microscope is good enough, I can prove that you did it wrong. Okay, you're not going to hit it right exactly where it is. And if it looks good, I'll just get a stronger microscope. So I don't want people graphing like that. Some people will ask you to do it, do the best you can. You're making a sketch, and that'll get you there. The sketch will be okay, but you can't get full accuracy on that. So I call that one possible but not graphable. Let's look at this one. Y equals, how about negative 2x plus 6. Okay. It's possible because I see y, an x term, and a number term that's not 0, so it's possible. Is it graphable? This is the weird thing. Even though the 6 is over here, that coefficient is 1. Does 6 divide by 1? I get 6. Okay, so I'm going to need that later on. 6 divided by 2 is going to get me 3. Is it negative 2 make it negative 3? Yeah, but I'm just seeing if it divides evenly. 6 divided by 2 does. This is going to work. So I'm going to get started on it. Let x equal 0. So we're ready. We go negative 2 times my, y equals negative 2 times my 0 plus 6. Y equals 0 plus 6. Subtract the 6. Subtract the 0 if you want, but anyway, y equals 6. That wasn't too bad. Comma in between two parentheses. The y is 6. The other one is x 0, 6. Okay, not bad. Let's continue. This is also going to work out to an integer. So in this case, I got to let y equal 0 to get the other intercept. This is a y-intercept because it's a y value where the other is 0. This one I'm going to let the y equal 0, so I go 0 equals negative 2x plus 6. This is x sticks around. On this one, I have to solve an equation. I need to do more algebra to get it done. Algebra we should be able to handle, so we should be able to get this done and get it worked out. But it's not always the easiest of the ways to do it. So let's go ahead with this. I got my 6 there, and I got my negative 2x. You can subtract 6 off both sides, as most teachers will teach their students to do. And if you do, you'll have a double negative. You got to make sure you divide by a negative. You got to do that right. You got a lot of risk. But the answer will be 3. What I'm going to do is this. This has 0 x's here and negative 2x is there. Let me get rid of the worst bank balance for x by adding 2x to both sides in the x column. That is gone. 2x equals 6. No negatives, no muss, no fuss. How to finish this one? I'm going to divide both sides by 2, and my x is going to be 3. And now I'm going to see that 3, 0 is where that's going to go. And I can plot those 2 points, and I will have used intercepts to find it. But was that the simplest possible way? The thing is, 6 is over here instead of this thing ending up by saying equals 6. Like this one said equals 7. So if that survived the possible, after being possible, if it found out it was graphable, that'd be awesome where the 7 is. But with the 6 being over here, not isolated because of the negative 2x, you're going to have to do algebra besides arithmetic. So you're going to have to know the algebra to get here and the algebra to solve that equation. And a lot of times people get the signs wrong. So if we can avoid that, maybe we should. So I'm going to look at one more. One that I would call a case where it is simple. All right, we've got the cases of not possible. We got the cases where it's not graphable with integers. And now we're going to look at one that does all 3 and why it becomes what I call simple. And that one is 2x plus 3y equals negative 12. X term, y term, a number that's not 0. It's possible. Is it graphable? Does 12 divide by 2? I get 6. Does 12 divide by 3? I get 4. When I go do that, I'm going to get integers. This is graphable. Is it simple? Finding if it's simple is actually itself a fairly simple rule. It doesn't take up many words either. The negative 12 is my number and it's isolated. This will be simple. Therefore, this is the kind that all the way through what we learn, I think intercepts is a good way for lots of people to do this. Let's go. Let x equal 0. 2 times a 0 in parentheses plus 3y equals negative 12. 0 plus 3y equals negative 12. Feel free to subtract zeros. 3y equals negative 12. Divide by 3. Y equals negative 4. So that's what I got. My ordered pair, the negative 4 for the y and 0 for the x. Now, because of the isolated negative 12, the other one will also be straightforward. I am going to let y equal 0. When I let y equal 0, I'm going to keep the 2x plus 3 times my parentheses 0, you know it's not 30, equals negative 12. 2x plus 0 equals negative 12. 2x, you subtract the zeros if you need to, equals negative 12. And divide by 2. So now here's my ordered pair, where my x is negative 6 and my y is 0. And in that case, I think it is best for most people to go ahead and use this concept. You don't have to memorize all that, but be aware that they're out there when you're thinking like, what should I do? What you think about should be related to that. So I'm going to have us take one more look at that board, maybe zoom in on it a little bit, because I didn't write that up for you. This is a bonus episode, so I wanted to just make that available to you and let you see that that's how we can make good decisions. And to me, that's what algebra is all about. Not who can add fractions well, but can we help you make the best decision with the information you have. All right, I'll talk to you soon.